All right. Probably not the most exciting topic to end the day, but something that's important for you to know about, and I get to cover the really exciting part, which is the regulatory part, and I know you're just dying to hear all that. I could sense your excitement. So a little bit of just an outline of what we're going to talk about. We're going to go through in more detail special water quality protections. We talk more about ORWs, ARCs, outstanding resource waters, aquatic resources of concern, endangered and threatened species, impaired waters, and then we're going to go through the buffer requirements. And then Dr. Vogel's going to follow me up, and he's going to talk about the models that are available to calculate sediment load reduction. So special water quality, we've covered a lot of this already today, so we'll kind of go through this a little bit quickly. I don't think you guys will mind too much if we end early. I don't know. I think you guys will be okay. So ORWs, again, waters of the state designated in Oklahoma water quality standards include Illinois River and Lee Creek watersheds, as well as the Mountain Fork River watershed. Addendum F of OKR 10 indicates the locations. We also tried to pull up FlexViewer, which is why we're having so many difficulties with technology. We wanted to get internet access and we didn't have it, so we can't go through that. We're hoping we can get that resolved tomorrow and go through a live demonstration of how to use our FlexViewer on our website. So fingers crossed that that works, and if you won't be here tomorrow, I apologize that we couldn't make that happen today. The map you guys should be familiar with, showing where Illinois River and Lee Creek watersheds are located, as well as the Mountain Fork River watershed. The aquatic resources of concern include sections of the following that you can see here, like such as the Grand Neosho River, Cimarron, South Canadian, Mountain Fork, Spring River, Illinois, etc. That includes certain watersheds as well. What you should note that there are certain counties that don't have any stormwater discharge sensitive, endangered, or threatened species. And those are listed here. So if you're working in one of those, you're not in an ARC. So that's good to know. All right. The updated map is here that shows the watersheds that are either aquatic resources of concern. For, again, what are these requirements that we have for these ORWs and ARCs? Make sure that you indicate that you're in one of these on your notice of intent and address it in your SWP3. No, I talked about that before. The inspection requirements are a minimum of once every 7 days and within 24 hours of a stormwater event of ½ an inch or greater, or within 24 hours of snowmelt related discharge, like Michelle was talking about in her presentation. Stabilization requirements for your sites if you're in these watersheds, like we talked about, they should be initiated immediately following the day earth disturbing activities have temporarily or permanently ceased. So again, the emphasis here is on getting cover in place as soon as you're done disturbing it to minimize the sediment that's exposed. And then complete those stabilization requirements within 7 days. Corrective actions are required, as Michelle talked about in her presentation. For sites that discharge to ORWs or ARCs, there's a 100-foot buffer zone required. We touched on that a little bit this morning. And if you can't provide the entire 100 feet from the water that's adjacent to your site, you can't supply 100% of that, what's required, then what you can, as an alternative, you can use Addendum I, which is a buffer guidance that we included in the permit to determine what kind of equivalent controls that you could put in place instead of providing that buffer. And then again, with the sediment basin, either a temporary or permanent sediment basin should be provided for areas that serve, that drain 5 acres or greater to 1 point. Specifically for sites that discharge to ARCs, they have to be protective of the listed or endangered species or the designated critical habitat if that applies. And you have to comply with all the requirements and conditions that are necessary to meet the eligibility requirements. Should note that the permit does not authorize discharges that cause a prohibitive take or that are likely to jeopardize continued existence of the species or habitat. And the procedure for assessing the potential effects of your discharge on one of the listed species is covered in Part 11 of the permit. You need to go through that process before you complete or submit your NOI. The first step in that process is to determine if you actually are in and will discharge to an ARC. If you don't, then you're done. You don't have to do anything further with it. But if you do, then you have to implement stormwater controls that protect that listed species. So as part of that, retain sediment as much as you can, establish the buffer zone or provide the equivalents, and then follow the stabilization requirements. You have to certify that you meet at least one of the following criteria as part of this process, either that you're not in an ARC, or if you are, that your SWP3 then describes where that area is and the measures that you're going to use to protect your species or habitat. Or if you can't do that, then you must certify that the site's is federally approved or authorized and addresses Endangered Species Act Section 7 consultation. So include that documentation in your SWP3. Or if you can't do that, then if there's another site in another operator's that another operator has, you can use their certification of eligibility on that. If you can't meet any of those above, then you can use the buffer guidance to select equivalent controls, or you can contact DEQ for guidance. It used to be that you'd contact U.S. Fish and Wildlife. They would prefer now that you just contact DEQ, and then we will help you with that on determining alternatives for equivalent sediment control. Okay, for impaired waters, those are identified on the 303D list. You can find the 303D list on our website. Again, like we talked about this morning, deals with waters with approved or established TMDLs and waters for which a TMDL has not yet been established or approved, but it's listed on the 303D list. And here's the location where you can find the 303D list and a location for the approved TMDLs or watershed plans that DEQ currently has in place. If you discharge to receiving water that's on a 303D list, you have to document how your BMPs will control the discharge of the pollutants of concern. So whatever that pollutant is, make sure you find a way to address that. And if there is a TMDL in place or there's a watershed plan that's been approved, then you have to make sure that your SWP3 is consistent with whatever is in that TMDL. For sites that are within a mile of the streams that are impaired for sediment, or make sure that you indicate that on your notice of intent. Again, the inspection requirements are once every 7 days and within 24 hours of a storm event of a ½ inch or greater, and the snow melt related as well. You have to document your corrective actions within 24 hours of discovery and implement them within 7 days. Stabilization, again, same requirements as for your ORWs, ARCs, immediately following the day the earth disturbing activities have ceased and completed within 7 days. All right, so that's the basics on what's required for impaired waters and then ORWs and ARCs. So now we're going to talk about the buffer requirements. There's 2 buffer requirements. For the first alternative is for sites that discharge to waters that are not an ARC or an ORW. So for those of you that are in this area, you've got a creek or a stream that's either running through your site or immediately adjacent to your site. You have to provide 50 feet of natural buffer undisturbed as measured from the top of the bank to the disturbed portions of the site. Okay. If you're in the ARC or an ORW, then it's the 100 feet vegetated buffer that you have to provide for perennial and intermittent streams. For those ephemeral streams or drainages, it's reduced down to 50 feet that you have to provide on that one. Okay? And what we want you to do with this buffer requirement is to retain and protect as much of the undisturbed natural buffer from your construction activities as possible. And you have to do that through the final construction, through complete build out of your site, so the length of the project. If you have pre-existing structures or impervious area already in the buffer area that you would need to protect, if it's pre-existing, then it's allowed to be there. You'll just have to document that and figure that into it. You should have some undisturbed beyond that if you can provide it. If not, there are some alternatives that we'll talk about. And then once you've got that buffer, if you've decided you can provide any buffer at all on your site, then you need to make sure through the length of your project that there are no earth disturbing activities that are conducted within that during permit coverage. And then ensure that all of your discharges are first treated by erosion and sediment control before they enter the buffer. So you don't want to have just sediment-laden water hitting that buffer without encountering, say, silt fence that you're using as your perimeter control first. Okay, and again, if you have water crossings, limited water access, or you have a 404 permit for activity that, for stream restoration activities, then this buffer requirement does not apply. Or if you have a site where no natural buffer exists because of pre-existing development, then again, the buffer requirement does not apply. Okay, so hopefully that's a little bit clearer as far as who needs to have buffers and how big your buffer has to be. And so there are some compliance alternatives. If you cannot provide the 50 or 100-foot buffer that's required, there are some alternatives. The first alternative is go ahead and provide it if you can. If you can't, how much can you provide? If you can provide 25 feet, try to maintain that and then provide some sort of equivalent control that will reduce sediment to equal what a 50-foot or 100-foot buffer would have provided. And then alternative 3 is you can't provide any buffer at all. It's just not possible with your site conditions. If that's the case, then you have to put in equivalent erosion controls that would achieve the same sediment load reduction that a 50 or 100-foot buffer would have provided had you been able to put one there. Okay. So one way you can do this to figure out what kind of equivalent controls you would need to put in place is use Addendum I in the permit. And it spells out all of these steps and will walk you through this process. The first is to determine if, first of all, is a buffer required? If it is, which compliance alternative are you going to use? 1, 2, or 3. If it's alternative 1, measure your existing buffer width and retain and protect that buffer width. So go out to your site, measure it off, and find some way to identify it to your bulldozer operator that he can't go any farther than this when he's leveling out the site or doing whatever activity that he's doing. And then the way it's measured is measured perpendicularly from the ordinary high water mark or the edge of the stream. And then for meandering water bodies, just measure it at regular intervals, and we'll kind of talk about here. This is an example of, in order to measure here, what you'd do is you'd find that where the vegetation starts to establish itself and be pretty well covered there, you start there and measure back towards your construction site. And if this is 10 feet and then this is 40, then you've got your buffer here. It's not a straight line. You don't have to have 50 feet linearly this way. This all counts into that slope, however long that slope is, that all counts into your calculation of whether that's 50 or 100 feet that you can provide. So bear that in mind when you're measuring for your buffers. If, however, you've got a channel like this near your site or running through your site, then you're not going to have as much slope that you can take credit for. You're going to have to measure from here back when you measure your buffer width. Okay? If you can't provide the entire 50 and 100 feet, and you select alternatives 2 or 3, if you select alternative 2, document the width and location of the buffer that you can provide in your SWP3. So include that on your site map if you can, or put a narrative in there. It's one of those things, as we work through it, we'll refine the process, but make sure it's listed in there in some way so that we can find it and know what you can provide and where it's located. Document why it's infeasible to provide the entire length or any at all. Again, like Joe said, I think, or others have said, paperwork is key on this. Documentation is key. We like to see the documentation. So make sure you're doing that. Determine what additional controls must be implemented along with any of the retained natural buffer. Okay, and the process is listed in Addendum I, and we're slowly working our way towards that. So it'll be a BMP of some kind that you put in place, or a combination of BMPs that you put in place to provide that equivalent sediment reduction. Okay, so for instance, if your site looks like this, there may be a point where you can provide, say you're in Oklahoma County, and you can provide the 50 feet of buffer. You won't have to do anything additionally on this part of your site. But up here at this part of your site where you can't maintain the 50 feet, then you'll have to put some other controls in place in order to match up that equivalent sediment reduction. Okay? So in order to determine equivalent sediment reduction, you have to first estimate what the removal efficiency is at a site if you could provide the 50 or 100 feet buffer. So, and then provide the equivalent sediment controls. It's dependent on a lot of site-specific factors, precipitation, soil type, etc. But you can use the tables in Appendix I, tables I-1 through I-4, in order to run through this calculation. Or if you choose to go a different, and that's one route. You can use the tables. That's one route we've provided for you. If you decide not to use the tables in the permit, then you can use a site-specific calculation for sediment removal efficiency. There are plenty of tools out there. There's the Revised Universal Soil Loss Equation and some other models that Dr. Vogel's going to talk about that you can use to do this calculation, or you can use Appendix I. And I'm going to run through how to use the tables in Appendix I. And one thing I wanted to note in that is that these tables were developed by Dr. Vogel and Katie Bites at OSU. And we appreciate their hard work on getting those tables developed for us. And you have to choose the vegetation type that most closely matches the vegetation that would have existed naturally, regardless of what condition it might be in. So it's not like if you had weeds out there, it's not like you would have to go out and plant a specific type of grass in that buffer area. You would just use the natural condition, which is weeds. Okay, so I'm going to walk through an example. Hopefully this will work. I haven't tried this type of example out yet, so you're going to be my test audience. So here's how I thought about doing this. I'm developing a commercial site in Oklahoma City. How do I know if I need to have a buffer? That's one thing. Okay, so take a look at your site and how close is it to the nearest surface water. Okay, in this case, you're adjacent to a surface water, and we're going to say you own and are going to develop this entire site, so you have control of all of this. So you will have to provide a buffer. These requirements do apply to you. Okay, so we've got that. You've looked at your site, and it looks like you're going to need to clear ground within the 50 feet of the stream buffer. Okay, so we know we're in Oklahoma City, so it's likely we're not in an ORW or an ARC, right? So this isn't going to apply to us. We're going to need to have 50 feet of buffer. But I've looked at what's going to go on at my site, and I'm going to need to clear ground within that 50 feet in order to build whatever it is, a parking lot in this instance. Now what do? So you know you can't provide the 50 feet, so alternative one is out. Okay, well, a buffer is required, not an ORW, so you need your 50 feet. You know you need 50 feet, you can't provide it, what's next? If you can't provide it, then what you're going to have to do is determine how much of a buffer can be required and what equivalent sediment control measures you're going to install instead. Okay, so we know we can't maintain the buffer. Now what do? You can use the tables in the appendix to determine the sediment reduction of a 50-foot natural buffer. So if I was able to leave that 50-foot a natural buffer, here's what my sediment reduction would have been, okay? So we know we're going to need these key pieces of information for the table. We're in Oklahoma City. Our natural buffer vegetation would be weeds if we could provide it. The site condition is a blade fill, and the soil type is a sand, okay? So we're going to go to the table. Table I-1 is for a blade fill in the Oklahoma City area. We have weeds, and a 100-foot buffer would provide 48% of sediment removal. A 50-foot buffer, which is what we need for our site, is going to provide 41% sediment removal. So you're going to have to provide equivalent sediment control measures to provide 41% sediment removal. Okay? 41% is where we're headed. This is our aim, this is our goal. So you found what a natural buffer would be. How do you determine what the sediment controls are that would provide an equivalent sediment load reduction? Okay, so we're going to have to select something. In this case, we've got in the table some select BMPs and what their sediment removal efficiency is for specific soil types. So you can either use what's in the table, or you can use another model and model what those what those sediment controls would do. Okay, for this instance, we're going to go back to the tables. Okay, so in this one, I decided I want to use a 12-inch wattle instead of as my alternative. So looking at the table, there's what we need to meet, what we need to match. I chose a 12-inch wattle, so using the table, that provides 90% sediment removal. So providing that wattle will meet what a natural buffer would have provided. So that's your equivalent measure. So what you would do then is, on your site, instead of having the buffer, you'd install your perimeter control and a 12-inch wattle, and that will provide the sediment removal equivalent to what a 50-foot buffer would have provided. Okay. Hopefully that's a little clearer. I know this is going to be an interesting process as we move forward with it. Okay? And just kind of an update on that 90%. So, are you done yet? You've decided what you're going to put in place. What else do you have to do? Well, here comes the documentation part. Put it in your SWP3. Say that you used Appendix I, if that's what you used. If you didn't, then you'll have to provide us information on the specific removal efficiency and the other information for your site-specific calculation. And you'll have to give us what stormwater controls, what the model was, and the results of the calculation in your SWP3. So you've got two alternatives. If you use the tables, say you use the tables. If you don't use the tables, then give us the information on the model that you used and what the results were. Okay. Again, so what if you don't use the tables? There are other calculation methods available, and that's what Dr. Vogel is going to talk about.